Today we're going to be doing an overview video on the complete RV power system, how it works, the individual components involved in making everything work, to give you a better idea when things go wrong on how to track down where the source of the problem is, and hopefully give you a little idea on how to fix it. First, we're going to start with the generator and shore power inputs. So shore power is obvious. When you go to an RV park and they have a pedestal there, you're going to plug your cord in there and then plug it into your RV. If your RV came with a built-in generator, you will have that alternate power as well. So to make sure that these two pieces of equipment and these two power sources never touch each other and combine, because that can end in some pretty catastrophic damage if those two pieces ever backfed one or the other. To mediate that power and make sure you never get two power sources combining together, we have our first component here called a transfer switch. So a transfer switch allows two power source inputs and only allows one to exit the transfer switch as the output that feeds your main breaker panel. So you have generator on or shore power on, it will pass through one or the other. If for some reason you are plugged into shore power and someone accidentally started the generator, instead of backfeeding power to each other and ruining the generator possibly or causing some serious issues inside the RV somewhere, this piece of equipment does not allow that to happen. So a transfer switch takes two inputs and outputs one of them. Usually the shore power side of a transfer switch is the dominant side. So if there ever is two sources at the same time, it will just pass through the shore power side. After it comes out of the transfer switch, it lands into the back of your 120 volt / 12 volt breaker panel or distribution panel. If you have a 30 amp powered rig, you will see a single 30 amp breaker in here, followed by some 15 amp and 20 amp load breakers. If you have a 50 amp RV, 50 amp power to your RV, so 50 amp service, you will see usually in the middle of the box there will be a 50 amp breaker that is referred to as a ganged breaker. It will look like two breakers, but the throw button in between, the throw switch in between on the breaker itself will be connected, and that's called ganged. So a 50 amp gang breaker will be one source of power on one side and the other source of power on the other side, usually a black wire and a red wire coming in, one on each side of that 50 amp breaker. And then all the other load breakers coming out of that will be on the left and right of that middle center 50 amp breaker. And those will be the individual breakers for all your other loads, like a microwave, a converter, your air conditioner, outlet strings, all of that stuff will have their own individual breakers here. At the same time, in this distribution panel, most times it will also encompass not only the 120 volt power side, but also a 12 volt power side like we have on this one here. So on this one here, you have your main breaker area. This is where your 50 amp breaker would be. And then you have individual slots for other loads, such as microwave and air conditioner, like we just talked about. And then on the far right-hand side, you have this area here that has a main positive and negative battery terminal, and then a bunch of places for you to add fuses here. And you can run lines from those fuses out to your 12 volt appliances. So your 12 volt DC loads would be stuff like your water pump, your lighting, all of that good stuff that you're going to have running in your RV, whether the generator or shore power is supplied or not. So moving on from there, we have what's called your converter, not to be confused with an inverter. They do opposite functions, and they can both be in your RV simultaneously, but they do not perform the same job. So a converter is your battery charger when you're on generator or shore power. It has a normal household plug in most cases that plugs in a lot of times to the back of your 120 volt breaker panel. There will be a little plug back there. These will plug in behind them. And then on the other side of your converter, you have the positive and negative battery lines coming out. So this takes in 120 volt power, converts it back down to 12 volt DC power, and supplies that over to our bus bars here pictured. And that charges your battery while the generator or shore power is running. So if you have an issue when you're running your generator, or you're on shore power, all of your breakers are good, none of them are tripped, and you do not have any charging going into your battery, this is usually the culprit itself. It's usually failed, or you have some kind of issue with power making it to it. So that would be the place to check for that. On the other hand, we have an inverter. Does the inverse function of a converter. So your inverter takes battery power, positive and negative 12 volt battery power. It converts that to 120 volt AC power, and it puts that out usually on the face of it. It'll have some things here. So we got 3 outlets on this one in the front, so you can plug an appliance like a microwave or something straight into it, but it also has a hardwired 120 volt output spot here where you can land a Romex wire or something like that to feed an appliance that way as well. So your converter takes 120 AC, converts it to 12 volt DC and charges your battery. The inverter takes 12 volt DC, converts it to 120 volt AC and powers appliances, normal household appliances. That is the majority of the components found on every RV. And then I added in some other ones that most people add themselves, or if you're buying a brand new rig these days, a lot of them are coming with some of this equipment. So we'll jump into that as well. The first one up here, we have our solar charge controller. Your solar charge controller takes your power from your solar panels into the input, and on the output side, you have battery power that you connect in, and it provides charging to the batteries through the charge controller. The charge controller is the mediator between the voltage coming down from the panels. So on this one, this is a 100/50 from Victron. So the maximum solar panel voltage input is 100 volts. But obviously, we can't feed 100 volts to our battery system, or we'd be frying some stuff pretty quickly. So this takes 100 up to 100 volts input. It converts it down while monitoring the battery. It converts it down to whatever the battery needs and is constantly monitoring that battery's voltage and state of charge. So it knows how much power in amperage versus voltage to step up or step down to finish charging the battery in the most efficient way. That is the purpose of the solar charge controller. Down here, if you have a lithium battery, chances are you also have a shunt installed, or if you don't, you probably should. A shunt basically sits between the negative battery post and all negative battery connections. So it is a directional piece, and this will need to be installed in the right direction. One side will be labeled battery. The other side will be labeled charging/loads usually. So you will have your negative to here, and then everything else will connect here. So that anytime something is used on your DC system, the power has to physically run through the shunt, whether it be from the battery out to the appliance. That would be discharging the battery and cause your state of charge to be going down. Or if you have solar inputting and it's charging the battery, that would put you in a charging state, and this would show your state of charge is going up and increasing. So it monitors all power in and out of the battery to give you an accurate state of charge of a lithium battery, or any battery type really, but most times, most other batteries like AGM and lead acid batteries can be monitored fairly accurately with voltage numbers. Lithium batteries are not that way, so they almost always require a shunt. If you have a drivable RV, a Class A or Class C RV that has alternator charging for your house batteries, you may need to consider placing a DC to DC charger as a device that mediates the power from the alternator to the house batteries. If you have that charging circuit and you've switched out to lithium, lithium is capable of pulling a lot of charging power, much more than a lead acid or AGM battery. So for those reasons, you do not want to max out your alternator all the time. It will cause it to go out prematurely. So to protect our alternator in these cases, when we upgrade to lithium batteries that can pull a lot more power, we need to put a DC to DC charger in line on that charging circuit to make sure that we can moderate how much power is being pulled, and we're not just letting the batteries request everything they can, which then hurts the alternator over time. So a DC to DC charger takes the input from the alternator and the output is sent to your main house batteries. Its main function is to limit the amount of current from the alternator so we're not overtaxing the alternator. Several companies make these. Victron is the one that we use most. They have an 18 amp, a 30 amp model, and now they have just released a 50 amp model. So you can choose how much amperage you'd like to be sending to your batteries according to how much amperage you have left over to safely run your alternator charge. So that is the basic overview of the RV system as a whole. If you guys have individual questions or want some more in-depth knowledge on each of these components, check back on the YouTube channel. We will have an entire playlist for all of this stuff, and we go very in-depth on not only the components themselves, how they work, but also we take a look at how to install them and things that we've learned over the years installing all of this equipment, so you don't have to make the same mistakes that we had to figure out on our own. Thanks for watching. Have a great day.